Microwaves. When you first think of microwaves, you probably think of the microwave oven in your kitchen that you use to cook your ramen. But microwaves themselves are actually a type of electromagnetic wave with countless uses. An electromagnetic wave is a wave that propagates in both the electric field and the magnetic field, which means it's affected by things that have properties in either of these regions. As a wave, microwaves usually range from about 1 millimeter to 1 meter. For comparison, 1 meter is about the length of an acoustic guitar, while 1 millimeter is about the size of the world's smallest ant, the yellow ant. Within this range, microwaves are divided up into subsections, or bands as they are called, such as L, which is about 15 to 30 centimeters, S, which is about 7.5 to 15 centimeters, C, which is about 3.75 to 7.5 centimeters, X, which is about 25 millimeters to 37.5 millimeters, and K, which is about 11.3 millimeters to 16.7 millimeters.
Okay, it's important to note the length of bands because wavelength equals the speed of light over frequency. So different wavelengths indicate different frequencies of microwaves, and frequency is what determines what a microwave can penetrate.
Whether or not a microwave will go through an object is dependent on its electrical and magnetic properties. This is due to the fact that microwaves has both electric and magnetic field properties. So based on how the electric magnetic field is oriented will determine how microwaves penetrate the cells of an object. So what happens when you put a metal fork in the microwave? Kaplooey! It explodes! This is because metal is a conductor and thus has free electrons that can pick up the microwaves and absorb their energy and turn it into kinetic energy, which is then turned into thermal energy. In contrast to metals interacting with microwaves, microwaves act differently with molecules of plastic. The energy from the microwaves isn't absorbed in electrons like in a metal, and rather the microwaves pass through the plastic just fine. This is because in an insulator like plastic, there are no free electrons to absorb the energy of the waves like there are in the molecular structure of metal. This can be seen in these images when plastic is held up in front of a microwave emitter, with a receiver on the opposite end. When this happens, the receiver will get a reading. However, when a piece of metal is put in front of between the receiver and the emitter, there is no reading because the metal has absorbed all of the energy. Don't worry, in this lab we use microwaves with much lower frequencies than your house microwaves, so that way you don't cause the metal to spark. All of this talk about microwaves probably has you wondering, what do microwaves have to do with warming up your leftover food? Well, food is made of water molecules and proteins. So, when microwaves interact with these conductive water molecules, they rotate the molecules, and then they absorb the microwaves, converting it into kinetic energy and thermal energy, which warms up your food so you can eat your leftover spaghetti nice and toasty warm. But microwave ovens aren't the only places microwaves are useful. Microwaves can be seen almost anywhere. They're the waves in the wireless networks like Wi-Fi that let you surf the internet and watch Netflix. They're also the waves used in the radar to detect clouds that you use whenever you check the daily weather. Also, that radar is the same radar that's used in military technologies. This use of microwaves in military technology was what inspired the creator of the microwave oven, Percy Spencer, in the first place.
Alright, so here's what we've learned. We've learned what's a microwave. We've learned the properties of microwaves. They're electromagnetic waves. They can only pass through certain materials. They range from being the size of a yellow ant to a guitar. We've learned the uses of microwaves and why they have bands and their frequencies. Check.
Yeah.
In general, microwaves are quite an interesting phenomenon and one of the best types of electromagnetic waves for all the scientific properties and various uses in our daily lives.